Alright students, welcome to the next lesson of our Chapter 7 Bivariate Data Unit, and we're looking into Chapter 7e, which is determining the value of Pearson's correlation coefficient R, or just determining the R value. Okay, so whenever you see Pearson's correlation coefficient, it's just referring to the R value. Okay. Now in the previous lesson, we've learnt about what the R value is, and it is a numerical representation of a scatter plot's direction, its form, and its strength. So direction refers to which way it's going, so that's positive, and downwards would be negative. Form would be whether it's linear or non-linear. So linear means can you put a straight line through it. If it's non-linear, then your dots might look something like this, where it's slightly curved. So that's non-linear. And the strength refers to how closely compacted the dots are. So the more compacted they are, the stronger it is. If you can't remember the strength and the associations for them, you can look at this table here. It'll show you numerical values and where if a R value lies between, for example, these two decimals, then it is considered strong, positive, linear. Okay, so have a look through this if you need to again. I'll help you understand what you might consider an R value to be. Okay, so we're gonna look into how do we calculate the R value. Now remember the R value, like I said before, determines the how well two variables actually have a correlation with each other, if they have one. So if a graph is linear, you should have an R value of some sort. Okay. It can be obtained using this formula here, but don't be scared because we're not going to use this. Okay, instead we're just going to use ArcCAS to do it. So don't be too scared of that. So let's get into it. So how do we determine the R value using ArcCAS? Well, here's an example. The following data shows per capita the income in thousands and the carbon dioxide emissions in tons of 11 countries. Determine Pearson's correlation coefficient R, or the R value for these data. So before we start, let's figure out what is my EV, what is my RV here. Does your income, how much money your country makes, determine how much CO2 it will emit? Or does the amount of CO2 you emit determine your income? Bit debatable, but I would say the EV is the income. So if the richer a country is, the more likely the amount of CO2 they produce. So this is your X variable, and this is your Y variable. Okay. So if you've, I presume you already know what to do when it comes to bringing your CAS in here. So you need to put these numbers in your list and spreadsheet. So if you've forgotten how to do that on your CAS, list and spreadsheet is this green button, or if you go new document and then add list and spreadsheets. Okay, but I've already done it here. So here's my two columns, income and CO2. Make sure that you label the top column, the top cell in each column with a name, otherwise this will not work. Okay, and also double check your numbers are correct. Okay, so I've got my numbers, I've put it in. Okay, what's the next step? Well, actually, before I get into that, remember there's instructions here that you can use, okay, to actually get it, but I will show you using the CAS. So on your CAS, you've got your numbers, you've got your columns, you've labeled them properly. Now we go menu, statistics, stat calculations, and then we don't go to one variable or two variable. We go to A plus BX, so number 4 here. Okay, now from there, you want to make sure, remember, you understand what is your EV, what is your RV. So income is EV, CO2 is RV. So X variable is CO2, sorry, income, and your Y variable was CO2. Okay, so once you've done that, you can look down on your calculator, just scroll down a little bit, and there is your R value right there. So the one that says R is your R value, and this graph, if you were to put it in a scatter plot, will have an R value of 0.818344. Okay, and that should be the R value as well there. So the question here says the value of, actually, does it ask us to do it in, it doesn't say here to the significant figures, but if we were to do it in significant figures, we can see that in 3 significant figures, it's 0.818. So if we were asked to interpret this, okay, so if we were asked to interpret 0.8.8 as an R value, so if your R value was 0.818, okay, how do we interpret that? Well, you can use this table. Remember this. You can use this table to figure out where does 0.818 fall into. Well, it falls in between this bracket, 0.75 and 0.99. So if you're going to interpret it, it's a strong positive linear association. So when you interpret the R value, you would write there is a so strong linear positive association between, and then you got to write your EV and RV. Don't write EV and RV itself, but what is the EV and RV? So we know that the EV is income, okay, and the RV is CO2. So you would write there is a strong linear positive association between income and CO2. Okay, so that's how we write the full answer for interpreting that R value. Okay, let's move on. So the other thing that we also need to understand is how do we get the R squared value? Now the R squared value is what we use to get a percentage sort of number to actually help us also interpret the graph, the scatter plot in another way. Okay, so the R squared value on your CAS is basically the variable that says R squared. So right there. Okay, so you'll be asked to interpret the R squared value as well when it comes to some of your questions in year 11. Okay, and it's more or less the same way when it comes to trying to determine the R squared value, because if you have a look, let's go back to, let's delete all this. Okay, it's the same way with your CAS. How do you determine the R squared value? Well, put your numbers in, make sure you've named or labeled your columns, menu, stat calc, and then A plus BX. Okay, make sure you put in your proper EV and RV, so X variable, Y variable, and there it is, your R squared value. Oops. Okay, right there, R squared value. Okay, so how do we actually, what's the point of it? How do we interpret it? Okay, and what's the point of it? Actually, let me get into that. So the R squared, what does it tell us? So it tells us the degree to which one variable can be predicted from one another. So remember that the R value predicts the association between the two, yeah? Or it explains the association between two variables. The R squared value is slightly different in that it actually helps us understand what is the chance or the degree to which one variable will predict another one. So you can write the same, we might write the same actual definition there, but basically these two definitions will probably point out what it really means. So the degree to which one variable can predict from another, or can be predicted using another, and the variation in the data. It can be obtained using your calculator, the same way you got the R value. Or another way is also, if you think about it, R squared. Okay, so the term coefficient of determination, another name for it is R squared. You can actually obtain it just by squaring the R value. Okay, so for example, if you have an R value here of 0.82, to get R squared, it's going to be 0.82 squared. So on your CAS, okay, let's add a calculator, 0.82 to the power of 2, so squared is 0.6724. So the value of that would be, or the value of the R squared value, we'll put that here, 0.6, what was it again? 724. Okay, oops. So 0.6724. Okay, so that is the R squared value. Now, it won't really show it to you here, but you can't actually interpret the R squared value just by leaving it like that. The next thing you need to do is turn it to a percentage. Okay, so how do you turn this R squared value to a percentage? Well, you multiply it by 100. So this is the actual R squared value. Okay, so when he asks you for the R squared value, you just give this answer. But when it comes to interpreting the R squared, this is when we now have to multiply it by 100 or to get it into a percentage. So when you multiply R squared, which is 0.6724 by 100, the answer is going to be 67.24%. And this is how we interpret it. So if you have a look at this little sentence here, highly recommend that you'd put something like this in your bound reference, okay, where you have this following sort of format when you do your answer. So basically, whatever the percentage of the R squared is what you put here, of the variation in the whatever the dependent, or you could call this the RV variable, can be explained by the variation in the independent. This is your EV. Okay. Now in this question, we don't actually know the RV or the EV, so that's fine. But when we do know the RV and the EV from a equation, this is when we use this the format right here. So if we try to interpret this, if you have a look at this formula here, now we haven't really looked at formulas before that, but remember with most formulas, okay, and if you look back to year 10, you would have come across a formula that looks like this: y equals mx plus c. Okay, where y is the y variable, m is the gradient, x is the x variable, and c is the y-intercept. Okay, this is kind of like a similar, if you look at this formula here, it's a very similar format to this. Okay, now you've also seen before in our calculator, we use this y equals a plus bx. It's actually the same exact thing, it's just different letters switched around. So a becomes the y-intercept, b is the gradient, x is the x variable, and you've got y, which is the y variable. So we're going to sort of get rid of this now and just look at a plus bx. So y is the y variable, okay, and this refers to the IV or the response variable, and x is the independent variable, which is similar to the explanatory variable, the EV. Okay, so if you have a look at the formula down here, the RV or the response variable is going to be number, okay, and the EV or the explanatory variable is going to be time. Okay, so number is RV, which is the y variable, and time is the EV, which is the x variable. So if we try to now use the sentence, we can actually put that all in to determine and interpret the R values, or the R squared value. So if we try to interpret R squared, I can see that the R squared value, okay, is 0.4225. But remember, when you try to interpret it, you have to turn it into a percentage, which is what goes here. So let's turn that R squared value to a percentage. So 0.4225 times by 100 will equal 42.25%. So that means the R squared value is 42.25%, and that's what we put in here. So in terms of interpreting it, it's going to be 42.25% of the variation in the, so we put the RV first, so you always put in the RV first here, and then in the end you put the EV here. So RV, remember the response variable is number, so 42.25% of the variation in number can be explained by the variation in EV, which is time. Okay, so what that's saying is about less than half of all the variation happening in number can be explained by what's happening in time. So this doesn't look like it's a very, if I was to try and graph this, you might come across a graph that looks something like this. So it means it's not quite strong, but in some way it does. The EV, which is whatever's down here, for example, time and number. Okay, the EV, which is time, does determine in some way what the number is. Okay, but only about 42.25% of the data. Okay, so not a very large number. But that's what we basically use to interpret the R squared value. Okay. Okay, here's another question here where from this graph, this table, X and Y table, we're going to use these values here, to try and calculate R and R squared. Okay, and then that'll be it for that. So if you've already familiarized yourself with the calculator, you should know how to put this all in the CAS. Okay, I've already done it prior to, but you've got age and height. Okay, so make sure you've got the correct values in your CAS when you do this. We're just going to ignore this question here. We're not going to do that. I want us to just focus on this. Okay, so we're just going to interpret. So if you've forgotten how to do that on your CAS, as in how to actually get your numbers in here. So on our CAS calculator, put your numbers in, you go menu, statistics, stat calc, and then A plus BX. Remember the shortcut, you can actually use numbers to get that. So menu 414. Okay, so remember what's the X variable, what's the Y variable? Well, we actually didn't determine that, but according to this, age, okay, and height. Does your age determine your height, or does your height determine your age? Well, obviously, age will determine what the height is. Okay, so in this case, X variable is age, and your Y variable is height. Okay, so your R and R squared, looking at it over here, my R value is this, and this is my R squared value. Now don't forget, remember you can actually calculate your R squared value by squaring that R value. Okay, so in terms of interpreting R, so if your R value is, looking at my CAS again, 0.9, let's go to 4 significant figures. Yes, and 0.9409. Okay, 0.9409. Now, how do we interpret the R value? Remember, okay, the R value scale up here. Okay, so where does 0.90494 fall? Well, it falls in between these two values. Okay, so that means that 0.9049 is a strong positive linear. Okay, it's got a strong positive linear association. So when we interpret the R value, we would write there is a strong linear positive association between, and then you'd write your two variables, which we know is age, okay, and height. So between age, between age and height. So we'd write between age and height. Okay, that's how we interpret the R value. Now for the R squared value, so we can see that the R squared value, oh, it's already here, but the R squared value. So if I was to interpret R squared, remember that the R squared value is 0. We'll do 4 significant figures again, so 0.9409. Okay, but remember, if you were to interpret it, you'd have to turn it to a percentage. Okay, so if you wanted to turn it to a percentage, let me fix that. So turn it to a percentage, 0.9049 by 100. That would equal 90.49. Okay, so in terms of interpreting it, remember you can use this little format of the interpretation of the R squared value to do your answer. So tell me the percentage of the variation in what's the response variable, can be explained by the variation in what's the explanatory variable, or the EV. Right, so I would write here as an interpretation, 90.49% of the variation in, okay, and what's the response variable in height, I think it was, is what we determined as the response. So in height can be explained by, I'm not sure if we write the variation or just explained by, yep, by the variation in, cool, the variation in, and then what's the EV? The EV is age. So these are the main things you're changing, or you're including here. So you want to talk about what is the percentage, and then you explain what's the RV, and then what's the EV. Okay, when it comes to interpreting the R squared value. So that's how we interpret R and R squared. Go ahead and do your exercises for chapter 7E, and these are your questions right here. Okay, 1, 2, 3, 4, 5.